Hello, hello friend. Today I am going to discuss about chemistry periodicity. What is chemistry periodicity? And then first I am going to discuss about history of the discovery of the elements, and then I will discuss about the properties of chemical periodic tables, and then I will discuss in detail of what is the electronegativity, and electronegativity, ionization energy, and enthalpies of elements. All these properties we will discuss about in this video. So first I am going to the history. In 1869, Russian chemist first developed the periodic table and arranged in atomic mass. During that period, they have arranged atomic mass, but that arrangements are not fulfilled with the all properties, and all also not favor the properties of electronic configuration, all those things. So in 1930, one physicist came, whose name is Moseley, came and observed the elements on the basis of characteristic X-ray spectra, and the plots the frequency of X-ray emitted versus atomic numbers, and they got the straight lines, but they didn't find the straight line frequency versus atomic mass. So they have decided the nature of atomic mass are not fulfilled with the all elements. Therefore they decide that this straight line will give the some same features, properties of on the basis of atomic numbers. So they modified the Mendeleev tables, and new tables is known as the modern periodic tables, and stated that the physical and chemical properties of elements are the periodic function of their atomic numbers. That means the physical and chemical properties we can determine as a function of atomic number, not a atomic mass. So keeping all those things into his mind, they again develop, means determine the periodic properties on the basis of increase the atomic numbers. So for determine the atomic properties of the elements, we need to the electronic configuration of atom and atomic radii variation with their atomic numbers, and they first determine the properties on the basis of valence electron configuration, and second, atomic parameters. So valence electron configurations, first they fill the valence electrons in d n minus d orbitals of d and n minus 2 orbitals of for a block elements. As we know, the group 1 all elements goes to ns1 valence configuration, where n is the periodic numbers, and these valence electrons vary with group. As you know, this valence configurations means electron configuration depends on group. If you see alkaline group, alkaline earth metal group, ns1 ns2, and these are the uh, boron 13 group, 14 and 15, 16, like that. This is for boron, carbon, nitrogen, oxygen, fluorine, neon. So these are the pattern according to the fulfilling of valence electron. For this alkaline group, this is ns1. For this alkaline earth math, ns2 valence electron 2. For this boron 13 group, valence electron is 3, and 14 4, 15 5 valence electron, like that. As we know, the arrangements of electronic configurations little bit different. Here the filling of electron is on the basis of half fill and full fill subcells is more favorable, and here the filling of electrons, valence electron ns and minus 1 d orbitals. If you see here, this is the transition metals valence electrons, and filling of f orbital also here favorable half fill and full fill orbitals. See the configuration of cerium of a block element 6s2 4f1 5d1 and 6s2 4f3, like that. So now the properties they have determined on the basis of atomic parameters. In this atomic parameter, they have physical characteristics like atomic radii and ions, energy change association with formation, and vary periodically. First, atomic radii and ionization energy, electron affinity, electronegativity, enthalpy of atomization. These properties are the most important for the competitive exam. So now we will discuss about the atomic radii. What is the atomic radii? Actually, the atomic radii increase down the group, means top to bottom is decrease, and increase down to bottom and decrease left to right. Everybody knows these are the common factors. And d block atomic radii 5d series and 4d series are almost similar, if you see here. But if you see this p block and s block elements, the atomic radii is drastically increasing from top to bottom. If you see, lithium is 152, and if it goes down, the higher cesium is 265, and like that we have seen here also. So why this increase the radius of atomic radius going top to bottom? Now we will discuss about this. So why these things is happened? Due to the joint effect of penetration and shielding. There is increase in effective nuclear charge. As you know, increase the withdrawal of an electron, the result is smaller atom. If you go down the group, the electron occupies successive shell, out shell, or complete core or radii increase. But this thing is not applicable for transition elements, because due to the poor shieldings of the electrons, and this decrease of radius is also called the lanthanide contraction. Why do the atomic radii increase down the group? Because, as you know, if you go down the group, the new energy levels is increases, so that the proton, neutrons and electrons are also added if you move down the group. That's why the size of atomic radii is increases. If you see here, the energy level is increases and more numbers of electrons and protons and neutrons are added here. So this is the reasons why the atomic radii is increased down the group. So now we will discuss about these properties: ionization energy and electron affinity. What is ionization energy? Ionization energy is required energy to remove an electrons from the atoms, and electron affinity is the required of energy to form and ions. If you see the trends, ionization energy is increased in row from left to right and decrease down a group. Electron affinity is highest for elements near fluorine. If you see here, if you see this periodic table, the most highest ionization energy, first ionization energy is helium is more, because this is orbital is fulfilled. That's why more ionization energy, and more required ionization energy for the remove outer electron from this atom, so that it's have high ionization energy. And here, if you see, cerium is the lowest ionization energy of first ionization energy of these elements. So what I am saying here, here written the highest ionization energy for highest electron affinity of this fluorine atom, near to fluorine atom particular. Why this electron affinity is more? Because due to the Uh, this is also a region of electronegative, as well as the this is group is very near to the this is inert gas elements. That's why the electron affinity is more for case of fluorine rather than other elements. So energy means relevant means is relevant is the form of cations. Means if you provide the initiation energy to ionize the atom, then you form the cation. But electron affinity is how much energy you are providing for the formation of an ions. And this energy of electron is proportional to this z square upon n square. Z is the atomic number and n is the periodic numbers. See this equation E0 form is E which is E plus G in gas state. The first ionization energy, this is first ionization energy required for the form of cations, means cations form. Here if you see ionization is relevant to form the cations, so that here form the cation. First ionization energy is need to form the cation, and if you remove second electron, then use to second ionization is required here. Like that, an electron required, the another ionization energy is required for the removal of another electron. If you see here, aluminum and gallium trends are little bit different. Why? As you know that trend, the ionization may increase in the row from left to right, ionization energy increase, and down the group is decrease. But here is different. Aluminum is lesser ionization energy and gallium is more ionization energy. Why this happen? I will tell you. This is because due to the alternation effect. It's due to the intervention of 3D subcells. That's why this is happened in this case. And similar trend I also found in the transition metals. The ionization energy is increase from left to right and decrease top to bottom. But here only it is the exception due to the alternation effects. And this is the, if you see, this is the plots, ionization energy versus J effect square upon n square. This trend gives the straight line, means if you see here, this trend also follow this trends. We increase the go from left to right, in boron, beryllium, boron, carbon, nitrogen, oxygen. The ionization energy is increased in proportionally from this trend, because this ionization energy proportional to this trend. So this is the also evidence for the increase the ionization energy from left to right. Now we will discuss about the electronegativity. What is electronegativity? Electronegativity is the some Electro means some negativity natures on the elements or any means species. So what is the here trend? Electronegativity increase across a period, decrease down the group. If you see here, electronegativity increase from left to right but decrease top to bottom. And if you see here, electronegativity denoted by chi is the power of atom of elements to attract electrons to itself when it is parts of compounds. That means when any atoms of atoms as a form of elements of compounds attract electron to itself is known as electronegativity. Understood? That means any species have capacity to withdraw the electrons is known as electronegativity. Simple. And here the steric effect is more important for the nitrogen elements, and this is the exception. Here is not trend. Electronegativity decrease from top to bottom, but here the increase. Here also is some region of alteration effect due to interventions of the 3D subcells. Earlier I read if you see here this trend, the ionization energy is increase, but it should be decrease. So here it was some alteration effects due to the intervention of the 3D subcell, and here also same thing is happened due to the alteration effect due to the intervention of 3D subcell. Now fourth properties I will discuss the enthalpy of atomizations. What is enthalpy of atomization? It is basically how much energy is required to form the gaseous atoms. This is the main themes of enthalpy of atomization. Enthalpy of atomization increases bonding orbitals or fields, then decrease the antibonding orbital occupied. If you see here in these periodic tables, atomization energies is lower rather than other elements, and here also is lower, because if you see the electronic configuration of this alkyne group, it is needed only one electron for fulfill the orbitals. That's why the energy required, lower energy required to form gases for atoms. Like that here also. After that, inert gas means helium and neon, like that series is after that comes. That's why only one electron is needed for the P5. Outer electron is P5, so only one electron is needed to form the gaseous form. So that therefore only here needed lower energy to form the gaseous form. If we see this trend, first the enthalpy of atomization energy increase and reaches to this highest points 715, and then again is started to decrease. That's why if you see carbons, valence electron is 4. Not 4. 6, valence electron 6, but here the outer electron is 4. So 6 means here needed 2 electrons for fulfill the octet. And here we needed to how much electron? 5. Sorry, here needed 4 electron, here needed 3 electron, here needed 2 electrons, here needed 1 electron to fulfill its orbitals to form the gaseous form. That's why here more electrons is needed to form a gaseous. That's why it needs more enthalpy of energy, and here similar things is also happens. First that atomization energy increase goes highest level, means highest, it reaches to highest position, and then again decreasing. Similar things is happen also in this series. I mean this row. And this is the all about the properties of these periodic tables. So I am thinking that all you guys to understood the properties of periodic tables. Thank you. Please subscribe my channels. Thank you.